So for number 59 over here, they want us to take this sequence and they want us to graph it. So I've graphed using the software called GeoGebra. And once we graph it, they want us to decide whether the sequence is convergent or divergent. So it does appear to converge here, right? It does appear to be to behave very consistently the more that n goes to infinity. And so we're going to say that an is convergent. And it wants us to guess the value of the limit from the graph. And so if we look at the graph, it does appear that the more that n goes to infinity, the closer and closer it gets to a value. And this value is about here at 1/2, right? It's about this value over here. So our guess that the limit of as n goes to infinity of an is equal to 1/2. And I'm going to put a question mark here because that is our guess. And now it wants us to prove our guess. So what we're going to have to do here is we're going to have to prove that the limit is in fact 1/2. So we're going to have to take the limit as n approaches infinity of our sequence, which is the square root of, so that's the square root of 3 plus 2n squared divided by 8n squared plus n. So if we just take the limit as it is, we're going to get the square root of 3 plus infinity, because 2n squared, divided by 8 times infinity squared plus infinity. So we're going to get here the square root of infinity over infinity, and that's not really helpful for us. So instead what we're going to do is we're going to divide the inside part by the highest power, which is n squared, right? And the reason that we're going to do this is that when we divide by the highest power, we're going to get a bunch of quotients, just numbers and quotients. And quotients are really nice when it comes to infinity, because if we divide by infinity, it goes to 0. So what we're going to do here is we're going to multiply here the top and the bottom by 1 over n squared and 1 over n squared. So this is the same thing as the limit as n approaches infinity of the square root. That's going to be 3 divided by n squared. I'm dividing everything, plus 2n squared divided by n squared is just 2 over 8n squared divided by n squared is just 8. And n divided by n squared is going to be plus 1 over n, just 1 over n. And actually, let me make this root a little bit bigger so that it fits everything. So when we take this limit here, this is going to be the square root of 3 divided by infinity. Well, that just goes to 0, right? So 0 plus, and then the limit of 2 is just 2 over the limit of 8 is just 8 plus 1 divided by infinity. Well, that's just, that is just 0, right? So this is equal to the square root of 2 over 8, which is the same thing as the square root of 1/4. And the square root of 1/4, it is 1/2. So we've gone ahead and we've proved here that our limit is in fact 1/2. So I can go ahead and I'm going to remove that question mark and just put a check. So we've proved that an is convergent and that the limit is 1/2.